In 6th grade standard EE9, students extend their work writing one variable equations to two variables in order to describe relationships between two quantities. In previous grades, students have described relationships or patterns in a table and graphed ordered pairs. Now students formally describe relationships with an equation. This standard is closely related to 6RP3, where students use ratios and rates to generate tables and equations, in that 6EE9 also targets proportional relationships. In 7th grade, students continue to generate and analyze relationships using equations. The following discussion and tasks serve as support for interpreting the standard and seeing it in action.
How would you want kids to articulate or explain what an independent variable is?
I would describe independent variable to my students, and I've done in the past, as the variable that is able to stand alone. Okay. It's the one that you put into the function or the
The idea is that's your dependent variable. It's dependent upon what happens to the independent variable, right? And so the one that really truly stands alone is independent, whereas the dependent is really dependent upon the other.
In my classroom, we use the language input and output a lot also. This is what we're going to input into the independent variable, and the dependent variable is our output as a result. My students, if you can find the unit rate, you can find anything. If you can find per one, then you can make a prediction for forever for whatever that unit is way out there.
Right, and that's what's important here is finding that unit rate, because that is how you write, you know how you said they could find everything. Finding that unit rate is how you write the equation.
Students use many forms to represent relationships between quantities. Representations include describing the relationship using language, table, an equation, or a graph. Translating between representations helps students understand that each form represents the same relationship and yet provides a different perspective. Focus on relationships that are proportional with the line passing through the origin. Students should be able to write an equation from a word problem and understand how the coefficient of the dependent variable represents the unit rate and relate it to a graph or table of values. The task Chocolate Bar Sales supports this learning.
Stephanie is helping her band collect money to fund a field trip. The band decides to sell boxes of chocolate bars. Each bar sells for $1.50, and each box contains 20 bars. Below is a partial table of monies collected for different numbers of boxes sold. Unit rate is for one box sold, they collect $30. So the constant would be the $30.
The two, not the 1 and the 30 and the 5 and the 150. So they've got two sets of variables there, and verify that the unit rate is 1 to 30.
In standard EE9A, students are required to write an equation to express one quantity as the dependent variable in terms of the other quantity, the independent variable. In relation to the standard is the illustrative mathematics task, Chocolate Bar Sales. In the task, students are required to write an equation for the amount of money M that will be collected if B boxes of chocolate are sold. Determine which is the independent variable and which is the dependent variable. The following are student examples explaining their answer to the identified question on the Chocolate Bar Sales task. The first student will explain the equation, and the second student will determine the independent variable and dependent variable.
M equals $30 times B. B equals boxes and M equals money.
I wrote that the B is the independent variable and the M is the dependent variable because you need to know how much boxes are sold to find out how much money they collected.
The learning target, analyzing a relationship on a graph, warrants time for exploration of how change in one variable affects change in another is shown in a graph. Although students will not write an equation for these relationships, the site graphing stories and the framework task of the same name build a foundation for analyzing the graph of proportional relationships like in chocolate sales in order to describe them in terms of its equation.
So I think at first when she walked upstairs, she would do a straight line on the graph. And then she runs back upstairs so her speed would increase. But then I think it would come back down. And since she walks at a steady pace in a circle, it would go straight again.
I think
instead like of having it as a point, it would go like a little straight and then dip back down, and then it would go back to its place. Steady pace, and then when she was running upstairs, she didn't keep on going. She was walking downstairs. And then she walks around a circle at a steady pace, so it goes back down.
You throw it in the air, it will kind of start going at a steady rate, and then it might kind of slow down, and then as it comes to the ground, it would come back at a kind of fast, but it might not be this one because this one doesn't show that it will come back down.
I think graph 4 could be right because whenever you throw it, it goes a little fast, but as it gets to the top, it loses its power as it gets to the top until it falls. It gets faster. But this one is kind of the same thing. It just is more steady.
In the EE9 standard, students are also required to analyze the relationship between the dependent and independent variables using graphs and tables and relating these to the equation. In the illustrative mathematics task, chocolate bar sales, students are required to graph the equation using the ordered pairs from the table. This specific part of the task does relate to the standard EE9B. As you can see in the clip, the students are drawing their graph based on the information from the table supplied in the chocolate bar sales task. The following clip shows a student addressing the chocolate bar sales task in relation to the graph and the equation.
On this graph, it says one box equals $30, and on this graph, it also says the same, and we use repeated addition to get how much money will you get in these boxes.
A formative assessment task that integrates technology and facilitates sharing of student thinking is Desmos' running game. Similar to a 3-act task, it begins with an image, a teacher-led notice and wonder, and a prediction. The activity asks students to make connections between the equation and graph, essential to SMP4, Model with Mathematics. It concludes with a video reveal and extension. To assess student learning, the culminating framework task, Want Ads, is a great choice. Look for student explanations of their equation in context as they choose a profession and analyze the income possibilities.